Welcome to a journey into the deep cosmos, brought to you by Dark Sky Dive, where we explore true engineering marvels. When humanity desires to peer deeper into the vast universe than ever before, the journey does not begin with powerful rockets. Surprisingly, the quest to understand our origins begins with a mirror, crafted with a level of precision that defies imagination. We are not talking about a bathroom mirror, nor the standard glass lenses found in your typical backyard telescope setup. These are the most precise optical surfaces ever created by human hands, sitting at the very heart of the James Webb. These mirrors do much more than simply reflect light. They are designed to collect the ancient history of our universe. They capture moments from when the very first stars were born, billions of years ago, bringing the past to us. To achieve this feat, humanity had to master the art of grinding matter with precision, down to the single atomic level. Why does James Webb need such impossible mirrors? Because it does not observe the universe using the visible light we see. It sees in infrared, the faint and weak heat signatures emitted by objects that are hidden deep within cosmic dust. It hunts for ancient galaxies, newborn stars wrapped in dust clouds, and distant planets orbiting alien star systems far away. To catch such tiny amounts of light, the telescope requires a mirror with a massive surface area to be effective. James Webb uses 18 separate segments joined together, creating a massive primary mirror that spans 6.5 meters. However, there is a deadly problem to solve. James Webb must operate at temperatures hovering around -233. At such extreme temperatures, almost every known material will shrink, distort, and completely change its original shape and precise curvature. Therefore, the mirrors of James Webb cannot be manufactured to the correct shape while sitting in a comfortable room temperature. It must be built wrong on purpose, so that the cold of space will warp it into the perfect shape. Standard glass was never an option. It would crack in the deep cold and is far too heavy for space. Instead, engineers chose beryllium, a rare metal that is incredibly light, yet stiffer than steel and stable in cold. Beryllium is a gray metal that is extremely lightweight, incredibly hard, and holds its shape in the freezing deep space. But beryllium is also a nightmare to work with. It is difficult to machine, and its dust is highly toxic. Each mirror segment starts as a rough block, which is then machined into a complex honeycomb structure to save weight. This honeycomb design removes most of the mass while keeping the mirror rigid, preparing it for the true challenge ahead. Now, the journey of precision grinding begins, a process that is not measured in millimeters, but in individual atoms. The grinding process for James Webb took years. It was not just about making it smooth, but making it perfect. The allowed error margin is less than 1/10,000th of the thickness of a single strand of human hair. If you stretch the mirror to the size of the United States, the bumps would be only a few centimeters high. The machines do not work continuously. They grind a tiny bit, stop, measure with lasers, and then grind a bit more. Millions of measurements are taken using interferometers and super-precise systems to ensure that every curve is absolutely correct. Every atom of material removed is an irreversible decision. There is no undo button in this high-stakes manufacturing process. But grinding at room temperature is not enough. The engineers must place the mirrors into a gigantic deep freeze chamber. They cool the mirrors down to near absolute zero, simulating the harsh operational environment of deep outer space. In that cold, they measure exactly how much the mirror shrinks and how the surface distorts from the thermal contraction. Then, the mirror is warmed back up to room temperature and ground again to precisely compensate for that specific shrinkage. This process repeats over and over. Grind, freeze, measure, adjust. A cycle of perfection that demands patience and extreme accuracy. Until finally, at -233 degrees, the mirror surface achieves a shape of absolute, undeniable perfection. Even when the shape is perfect, the mirror is not ready. Beryllium is dull and cannot reflect infrared light efficiently. James Webb needs to reflect infrared light with maximum efficiency. And the best material for that job is pure gold. A super thin layer of gold, only about 100 nanometers thick, is vapor deposited onto the surface of every mirror. This gold layer is so thin it is almost transparent, and light enough to not affect the mirror's weight. Yet, this microscopic layer of gold boosts the reflection of infrared light to the absolute physical maximum possible today. After the gold, a thin protective layer is added, ensuring the soft gold is not scratched or contaminated during handling. Now a new challenge arises. James Webb does not have one single mirror, but 18 separate, distinct mirror segments. Each segment has a slightly different shape and unique curvature depending on where it sits in the overall telescope structure. To act as one giant mirror, each segment is attached to ultra-precise actuators that can move it by nanometers. James Webb does not have a fixed mirror. It self-adjusts its own shape in space to maintain perfect focus. Once finished, the 18 mirrors are assembled onto the telescope's folding backplane structure, a process with zero room for error. The entire system must fold up like origami to fit inside the rocket, then unfold perfectly once in space. There are no technicians out there. No manual repairs are possible. Everything must work exactly right the very first time. Why is this precision so important? Because just a tiny misalignment would scatter the light and ruin the scientific data. James Webb observes the weakest light in the universe. Atomic-level precision is the line between success and a useless failure. When the mirrors open, they begin to do what they were born for, collecting light that left galaxies eons ago. They capture light emitted when the universe was still very young. Each photon touches a surface ground to atomic perfection. James Webb is a testament to human ability to control matter at the smallest scale for the biggest possible goals. From a block of raw metal to golden mirrors that can see through time. It is not just engineering. It is art. Let us look closer at the grinding head itself. It moves with a deliberation that seems almost alive and thinking. At the microscopic level, the tool is interacting with the crystal lattice of the beryllium, shaving off layers of atoms. Engineers constantly monitor the surface roughness. Even a scratch invisible to the eye would be a canyon to infrared light. If the surface is rough, the light waves scatter. The image becomes fuzzy, and the secrets of the cosmos remain hidden. But on a perfect surface, the light reflects in unison, preserving the information carried across billions of light years. Cleanliness is paramount. A single speck of dust during the grinding process could gouge the soft metal and ruin everything. The operators work in shifts, monitoring the machines day and night. The quest for perfection does not allow for sleep. Progress is measured in microns per week. It is a test of patience, where rushing leads to immediate, costly failure. Moving the mirrors between the grinding lab and the cryogenic chamber is a delicate operation requiring extreme care and planning. They are transported like national treasures. Any vibration or sudden shock during transport could undo months of grinding work. Back in the cold chamber, liquid nitrogen and helium are used to drive the temperature down to deep space levels. As the metal cools, internal stresses from the manufacturing process are released, causing the mirror to warp and change shape. The engineers compare the warm shape with the cold shape. They create a heat map of where to grind next. They grind the mirror at room temperature to be the inverse of the error they measured at the freezing temperature. It is essentially sculpting in reverse. You carve the shape you do not want, so the cold creates the shape you need. Once the gold is applied, the mirror becomes a jewel. It is beautiful, but its beauty is purely functional. Gold is also chosen because it is chemically inert. It will not tarnish or oxidize like silver or copper would. In space, reliability is key. A mirror that tarnishes over time would slowly blind the telescope and end the mission. The protective glass layer is amorphous silicon dioxide, It protects the soft gold without blocking the infrared light entering. Final inspections are rigorous. Even a fingerprint could damage the coating or outgas in the vacuum of space. Robotic arms assist in the assembly to avoid human error. The placement must be accurate to within a millimeter. The mounts are designed to hold the mirror securely during the violent shaking of the rocket launch without breaking. Launch is a violent event. The acoustic noise alone could shatter lesser mirrors. James Webb must survive this chaos. After the violence of launch comes the silence of space. The telescope begins its long journey to the Lagrange point. Before the mirrors can work, the Sunshield must deploy to block the heat. The telescope must cool down drastically. As the Sunshield opens, the temperature on the mirror side drops, and the beryllium begins to shrink into shape. The side wings of the mirror unfold. Now, all 18 segments are in place, but they are not yet aligned. The first images are not a single star, but 18 separate dots. The mirrors are acting as 18 different telescopes. From Earth, engineers send commands to the actuators. They tilt and shift each mirror segment by tiny fractions of millimeters. Slowly, painstakingly, the 18 dots are brought together. It is a process of fine-tuning that takes months to complete. Finally, the dots merge. The 18 mirrors now act as one single, giant surface. The telescope is focused. You can see the 6-pointed spikes on the stars. This is the signature of the hexagonal mirrors working in harmony. Compared to Hubble, Webb sees through the dust. The infrared light passes through clouds, revealing the secrets hidden inside. We are now seeing galaxies that formed just a few 100 million years after the Big Bang. We are time traveling. The mirrors are precise enough to analyze the atmosphere of distant planets, searching for the chemical fingerprints of life. It is humbling to think that this piece of metal, mined from the ground, is now revealing the universe's soul. For the workers who ground these mirrors, it was a labor of love. Their handiwork is now floating 1,000,000 miles away. These mirrors are so sensitive that touching them with a bare hand would ruin them forever. They are untouched by skin. Space is dangerous. Tiny meteoroids have already hit the mirrors. But the robust design allows the telescope to keep working. Engineers can even tweak the shape of the damaged segment to compensate for the impact, maintaining the image quality. James Webb is built to last. It will continue to scan the skies for a decade or more, changing our understanding. Always remember the scale. 1/10,000th of a human hair. That is the margin between discovery and blindness. A new generation of astronomers is now using these mirrors to answer questions that we did not even know how to ask. What will we find next? Another Earth? The very first black hole? The edge of the universe? The mirrors are ready. In looking out, we are also looking back. We are understanding our own place in this vast, ancient cosmic arena. It is a long way from a rough gray rock to the most sophisticated optical instrument ever built by our species. It took thousands of people, across multiple countries and decades of work, to polish these mirrors to their final perfection. The light hits the primary mirror, bounces to the secondary, and travels into the cameras. A perfect dance of photons. The secondary mirror is also beryllium and gold. It must be just as precise to direct the light into the sensors. The structure holding the mirrors is also a marvel. It remains stable and rigid despite the extreme temperature changes in space. Before launch, they shook the whole telescope to ensure the mirrors would not snap off. It passed every single test. The launch was a moment of holding breath. Billions of dollars and decades of grinding were sitting on top of an explosion. But it worked. The mirrors survived the journey. The origami unfolded. The gold began to shine in the darkness. Even looking at objects in our own solar system like Jupiter, the mirrors reveal details of rings and storms never seen. The pillars of creation, once opaque towers of dust, now transparent and filled with stars, thanks to the infrared gold mirrors. James Webb has set a new standard. Future telescopes will need to match or exceed this level of atomic precision. The lesson from these mirrors is clear. To see the furthest things, we must master the smallest things right here. It inspires the next generation. A child today knows that we can build the impossible if we are precise enough. The cryogenic polishing remains the most critical innovation, shaping warm metal to be perfect only when it is frozen. And beryllium, the toxic, difficult, but miraculous metal that stays stiff and light, allowing us to reach for the stars. And gold, the precious metal that we value for jewelry, now valued for its ability to catch the whispers of galaxies. Floating 1.5 million kilometers away, the telescope is a lonely sentinel, watching the dark sky for us. It speaks to us in binary code, sending gigabytes of data every day, rewriting the textbooks of astronomy and physics. Every week brings a new surprise. A new planet, a new galaxy, a new mystery solved by the golden eye. It turns its back to the Earth and Sun to keep cool, facing the eternal night to bring us enlightenment. From the atom to the universe. The connection is made through human ingenuity and the relentless pursuit of absolute perfection. These mirrors are more than just tools. They are a declaration that we want to know, and we will know. James Webb is the ultimate time machine, and it was built by grinding metal until it was perfect to the atom. The universe is no longer dark. It is full of color, heat, and history, waiting for us to explore it. If you enjoyed this deep dive into the engineering of the cosmos, consider joining our community of explorers today. We have many more stories of science, technology, and the mysteries of the universe waiting for you to discover. Thank you for watching. Keep looking up at the stars and never stop wondering about what lies out there. This has been a production of Dark Sky Dive. See you in the next video. Goodbye for now.